Welcome to Omega Virtual Learning. I welcome new viewers to this channel. In today's lesson, we'll be talking about congruence of shapes. This is the introduction lesson on congruence of shapes. And I hope by the end you understand the basic rules of congruence of triangles and also understand 4 basic ways or postulates of congruence. Two triangles are congruent if their corresponding sides are equal in length and their corresponding angles are equal in measure. In short, we can say same shape and same size. And for you to be very fluent in proving congruence of triangles, you must really understand properties of shapes and angles because they help a lot in proving congruence of triangles. Congruence of triangles could be proven using many conditions, but I'm going to go through 4 conditions according to postulates. The first condition is angle side angle. I may call it ASA. Side angle side SAS. Side 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 SSS. And right angled hypotenuse side RHS. I want you to note here that there is no angle condition. In proving congruence of triangles in particular, there is no angle condition. Angle is only to prove similarity of triangles. So note that AAA is for similarity, not for congruence. So let's see why triangles A and B are congruent. You check the information given and see which of the postulates will work. You can see same side 14 cm, so you put down a side. Same angle 25 degrees, that's an angle. Another same side 10 cm, so we can say the triangles are congruent by the condition side angle side rule. And note that for you to prove using side angle side, the angle must be an included angle. That is, they must be between the two proving sides. The angle must be an included angle. They must be between two proving sides, or the two proving sides should form that particular angle. Let's look at example 2. What condition will make these two congruent? 14 cm same side, that's a side. 10 cm also same side, another side. 6.5 cm same side. So we can say the two triangles C and D are congruent by the condition side side side. Third example, state the condition why they are congruent. Sometimes, given the information, you check and you realize that they don't necessarily match the postulates that you want to use one of them to prove. So when that happens, it is best to see if you can find out any missing angle. So here, let's try to find out the missing angle. And we know sum of interior angles of triangles add up to 180. So to work out the missing angle, we have 75 degrees. We can now check which of the postulates will work. We have 75 degrees, that's an angle. We have 10 cm as a side, and 25 degrees as an angle. So triangles E and F are congruent by the condition angle side angle. You must also remember here that for you to prove using angle side angle, the side must be between the two proving angles. The side must be between the two proving angles. Now pause the video and try to see whether you can prove this triangle A and triangle C, whether they are congruent by the condition angle side angle, side side side, or side angle side. When you are ready to listen, press play. Pause it and try it first. Okay, let's check. Hope you are done. 45 degrees, so same angle. 4.6 cm is the side. 64 degrees angle. So they could be proven using angle, side, angle. And as usual, remember, the side must be between the two proven sides. Example 4, we're supposed to prove congruence of triangles. ABC is equilateral triangle, so ABC, equilateral triangle. D lies on BC. D lies on BC. AD is perpendicular to BC. So we know AD is perpendicular to BC. Prove that triangle ADC is congruent to ADB. Now, we know this side is also 90 degrees because we've been given the question that AD is perpendicular. So we can say that angle ADB, and ADC are right angle triangles since AD is perpendicular to BC and is given the question. So we have a right angle. So that's the symbol right angle as a condition. Also, we know that given a right angle triangle, these two lines are the hypotenuse for each triangle. So that's the hypotenuse. And the hypotenuse are equal because remember, equilateral triangle, all the sides are equal. So the hypotenuse are equal because sides of equilateral triangle are equal as well. Then we have a common side to both triangles. So we have a common side equal. So this could be proven using the condition right angled hypotenuse and a side. So it has a right angle, it has common hypotenuse and a common side. So this condition could be used to prove the congruence of triangles ADC and ADB. So we are saying these two triangles are congruent by the condition right angled hypotenuse side. And lastly, let's prove why triangles ABD and ABCD are congruent. Remember, it's a parallelogram. So we start. We know that BD is common to both triangles. We're going to prove this in two ways. So this is the first way. BD is common to both triangles, as you can see. So we have a common side. Then we have BA is equal to CD, and opposite sides of parallelogram are equal. So that's also a side. Then we also have BC equals to AD, also opposite sides equal. So we can say triangle ABD is congruent to triangle BCD by the condition side, side, side. So that's the first way of proving the congruence of these two. Let's see if we can prove it in a different way. We still have a common side, so that's a side. We know that this angle is equal to this angle. Reason is alternate angles are equal. Remember, there's a parallel line here, that's a parallel line, and that becomes a transversal. So that is alternate angle, these two. And alternate angles are equal. We also know these two sides are equal because opposite sides of parallelogram are equal. So we have side, angle, side. Side, angle, side. So that's another way of proving that these two triangles are congruent. That brings us to the end of lesson 1. Watch out for lesson 2, where we go into more proofs of congruence of shapes. Lesson 2 will be focusing on proofs using any of the 4 postulates. Thanks for watching. Share with your friends.